Welcome to another video on my Raspberry Pi. Running Raspbian Linux using both a webcam and a Raspberry Pi cam. Last time I tried to get a line sensor from fischertechnik working, and that didn't go entirely as expected. The point is that I wanted to do it just like that, and a measurement showed that with this sensor connected to 5 volts, the output was decimal 1 volts, and that is far below any level that the Raspberry Pi can sense. So actually can sense as 1. I thought to do a transistor in between, but that is not going to work because let me show you the Scilab. Last time I did a Scilab simulation, and that showed actually that it didn't work. Well, the whole simulation didn't work, and right now I have it done in the previous version with 5 volts, which it remembers, and a transistor. And when I show the complete simulation, you see that the voltage from 5 volts drops after the transistor to 4 volts. Reason is that the transistor is a current amplification, not a voltage amplification, and Ohm's law says when one rises one constant, then the other one has to drop. Current rises, so voltage has to drop. So that is not a good idea. Not having a voltage amplification, by my knowledge, I have some new parts, but I have yet to figure out which ones. This is the end of an idea for the line sensor. So what next? Well, for now, exit the idea of this sensor. And what I can do is going towards a very different sensor, the light dependent resistor. Light dependent resistor is an analog device. The Raspberry Pi having only digital input, in comes a small chip which is an analog to digital converter. So that is what I'm going to do. Exit line sensor with infrared, and this is my next test. Will this have consequences? Well, I have to set it up where this is input to this, and then one line to a GPIO. Which will that be? I don't know yet. Anyway, this also proves, by the way, that since this flawlessly, of course, works on fischertechnik interface, there's absolute level difference, because that works on 9 volts. This is 5 volts, and I already, of course, tested it, and that works flawlessly. So if there's so much difference between the output of 0.1 volt. How did that go? Anyway, voltage amplification was at best, not working, end of story. Alright, I have put the ADC in place, and if you look closely here at the wiring, I have used some improvised wiring to connect it, the ADC, to the GPIO. Another problem is, though, that where comes the LDR? Well, in the set of electronic parts I found an LDR, which is much more suitably equipped for using in the breadboard. This one I have to wire, and of course it will work, but this is much more handy. In comes another problem, that for this one, and probably also for that one, I have to use a 10 kilo ohms resistor. And there's a problem, because according to this website, which has done everything for me, well, in theory at least, it needs a 10k resistor. And that's for me a problem, because I can't find one, and I have a lot of smaller ones, but to set them in series and make a 10k resistor, I don't think so. So that is a little bit of a problem. How to go on from here? Well, finding a 10k resistor is what rests for now, and then I can start my code. One thing though, here you find slave clock, MISO, MOSI. If you have watched my Arduino Mega 2560 videos, then these may be familiar, because this is SPI, Serial Peripheral Interface, and I've used it there as well. The only difference is I'm going to use this into Python, where well, that's my intention at least, where Arduino is in C, AVR C actually. But that said, I have to find a 10k resistor somewhere. So, off to find. Alright, everything is wired now, with one exception. I don't have a 10k resistor right here. This resistor is much smaller. Does that influence the circuit? Most likely. Another thing that is not quite working right now is this, so I will start it again. Can't be opened. Oh, right, it can't be opened because it's not doing anything. So I'll restart, close, then go, and there we are again. Very nice. Then this view. So now let's hope that things go work, and it is a little bit of a mesh right now, MESH, and I still have to find out if my previous wiring error, which is not, by the way, here, but has everything to do with this wire, because this wire was previously connected to 5 volts and is now to 3.3 volts, and the ADC is directly connected to the mains. So let's hope I didn't ruin things before I got started. That said, I need to get some programming done, and once again here what is said, which is which. Now if everything is alright, I don't have to program this because Raspberry Pi already has this implemented. If I go to, I hope is this one, then I see this is already clocked, this is already my sound, this is already MOSI, whatever. So is this already working? That's a good question. Not quite sure, but if I look right up here, SPI dev library for Python. I don't have that yet, so let's open a link. Right, this means I have to download it. So that's a nice one. So I'm going to do that and then find out if I get things working. This is Python, no doubt, which is exactly what I want. So let's see how that continues. Download, complete. Then there is something called downloads. Open. Yes, extract. To downloads, extract. Close, close, close. That's very quickly done. Now I have to uncompress and install things. Let's see how that works out. I made a small mistake. The SPI dev was downloaded on my laptop, not on the Raspberry Pi, so I need to do it from the Raspberry Pi, as you can see. Now one other thing is that in this documentation page I find that I can do it using wiring PI and wiring PI is already used by me for the soft pulse modulation, so I can use this also for the SPI, where SPI dev has a special driver, etc. So I keep using wiring PI. Another thing is that I need to run the Raspberry Pi configuration to set it, and right here with advanced options I can set SPI. Yes, I want that. It is enabled. Do you like it to be loaded by default? Yes. Alright. And then the same thing for future use, I2C. So yes, I'm going to load. Would you like it? Yes. yes. Future load, yes. So now I have to reboot it says BCN no such device. I don't like that quite as much, but we'll see what that whatever happens. In the meantime, I have to close everything because I have to reboot to get the SPI and I2C thing to actually do something. So stop this, close, close, and here close, and then I can say alright, shut down. And that's as far as this goes, and then you will see in this window whatever happens, and then I mean this window. So I'll let it open. You will have noticed that this is shut down. And here you can see whatever happens via the serial interface. And that's it. Here you see it, so it's going to reboot. Alright, everything is up again, and with everything loaded, and this website saying, the RaspberryPi website saying I2C and SPI also supported, so that is very nice. Only to find out how we can do that, but in the meantime I still have to check if this LED and this LED are still, no, this one, are still working on behalf or by the pulse width modulation that I have here. So in order to do that, I need to start this program and see whatever happens. Alright, at least this looks quite nice. Alright, and how does this support it? So I guess I need documentation. This is all about building it, but I already did that. This I made a mistake a long time ago. This is I2C, which I have to do sometime in the future. Setting up a peripheral. And that is nice. So wiring PI, MCP, this is I2C. So where do I go with my beloved SPI? That's a nice question. Very nice question indeed. This is serial. I'm okay with that, but I don't need that. So where is it? A very good point. It does say it supports it. How? Alright. then I figure out I need documentation more. So let's go to the documentation then. Right, final part of this video. I found some more information about SPI. The point is that this is in C. I'm doing it in Python. Although this is SPI in Python, this is about using an LDC with an ADC, LDR with an ADC, light dependent resistor, analog digital converter. Two different things. As you can see, not here, this one, LDR, ADC, GPIO. Well, at the end of this band there's GPIO. There's a lot to find out. How does everything work? I need everything to be correct, of course, hoping that my wiring mistake doesn't end up with a broken ADC. Still have to find out that. And in the meantime, that's it for now. So thank you for watching. If you like this video, please subscribe to my channel. You can also follow me, please, on Twitter and Instagram. Please donate to keep the things going. For more information, see also my website. I am also considering to set up a Patreon website, so you can ask for a video and pay me for it, because donations are none. And what else is there to say? This is going to be very exciting with well, somehow the blinking has ceased, even with the bare eye, and not a clue why, to be honest. It does work. It has probably to do with this being completely blank now. And now it works somehow. Except this. Let's open it again. Nope. Anyway, this is certainly to be continued. Bye bye.